I'm James O'Loughlin. Welcome to a special episode of The New Inventors. Recently in Victoria and regularly across our country, bushfires have wrought havoc. Overseas, hurricanes and earthquakes have devastated countries. No matter how technologically sophisticated we become, we seem to remain at the mercy of natural disasters, and yet there are people who continue to strive to invent ways to reduce the devastation that natural disasters can cause. Some disasters arrive in a matter of minutes. Others slowly gain momentum. The number and severity of natural disasters is increasing around the world. Every year, they claim thousands of lives. 12 nations were struck by the Boxing Day tsunami. The victims were from 51 countries. The wrath of Mother Nature is nothing new to us, but it is getting worse. Here in Australia, the number of people affected by natural disasters has doubled in the last decade. This year, we experienced our worst natural disaster in over 100 years. More than 2,000 homes were lost in the Victorian bushfires and 173 people lost their lives. That disaster was closely followed by floods in Queensland and New South Wales. Many scientists expect climate change to increase our vulnerability. And while it may be difficult to predict natural disasters, it is possible to limit their impact. There's no competition tonight, but I am joined by our panel. Hello to science journalist Bernie Hobbs, engineer James Bradfield Moody, and futurist and author Mark Pesce. For a long time, we've thought that bushfires are an inevitable feature of the Australian landscape, and if your home is in the way of one, there may not be much you can do to protect it. But here's someone who reckons that there is a way of building a house that will give it a far greater chance of surviving a bushfire.
This is my country. I grew up here and I'm passionate about this landscape. Anything I design must celebrate it. The peninsular location of this house is remote. There's only one way in and one way out. And there's another thing. Lightning loves this place as much as I do. In fact, it was incinerated only 4 years ago. So you could say it's a location to die for, but I wanted a place that would give confidence in the event of a bushfire. To this end, the house is sitting on structural steel stumps. Some of them lead all the way up to the roof. The timber floor is suspended and protected from fire by fibre cement sheeting. Perforated fire shutters are the main defence against ember attack and radiant heat. With no eaves over the windows, the shutters also control the sun. I want this window, the lowest in the house, to be a lens into the heath. It's fire-resistant double glazing, so the bush can grow right up to the house. The worst case scenario is when you've got a bushfire outside and a structural fire inside. In this house, we've got a fire-safe zone. And no doubt, the question you all want answered, would I trust my life to this house?
Please welcome from Brisbane, Dr. Ian Weir. Hey, Ian. What's the answer?
Well, it's about degrees of confidence, James.
Yeah.
And in this instance, it's not a house that is guaranteed.
Yep.
Or it's not like a product that's guaranteed. It's about giving the owners, which I've got an ongoing relationship with, the confidence to stay in this house if they don't have any option other than that.
Okay, so let's look at some of the features. Starting on the roofs, there's no eaves. You've minimised the places for embers to
That's right. It has a very simple geometry.
Yep. You've got fire. Tell me about the windows.
Well, the large windows, which are actually facing east, are protected from radiant heat and ember attack by fire shutters, which are perforated shutters. And the great thing about them is when you're inside and the shutters are down, you don't feel trapped inside. Okay, so there's an example of the shutters open and shut with holes in them. Too small, you'd say, for embers. That's right, they're only 1.5 millimetres in diameter. So that stops the embers that are a problem, but it still allows great visual contact from the inside to the exterior. And there's also a safe area in the house down here, which we saw
we saw in the package.
That's right. The important thing about the safe zone is that it still allows direct egress outside of the house. You're not trapped inside.
Yeah, we'll talk more in a minute. But now you've got a house designed. How do we work out how it would fare in an actual bushfire without having an actual bushfire? Well, that's where our next invention comes in.
The site sketcher measures and maps a building in its environment.
The data collected is used to identify the design and landscape feature on the building and its surrounding that makes it vulnerable to bushfires.
It's a scanning device mounted on a pole that uses 4 sensors: a rangefinder, a digital compass, a differential GPS and an inclinometer to take snapshots of the house and surrounding landscape.
The data is then combined to form a 3D sketch of the house and site that highlights potential bushfire risks in the design. The site sketcher creates a virtual window into how a building would perform under certain fire conditions,
so that you can give it the best chance of surviving bushfires.
Please welcome from Melbourne, Justin Leonard. Hey, Justin. Now, we saw in the package how you essentially harvest a lot of information from a site using that tool. You can do that on an existing house. So if you're rebuilding after a bushfire, you can plug 5 different designs, for example, 6, 7, 8 different designs, all into this and see which of those hypothetical houses will perform best under a bushfire and choose between the designs based on that information.
Yeah, that's right. So you can assemble a whole range of different scenarios with particular components you'd like to try and run them through a scenario and see how they really turn out.
Fantastic. Now, let's look at how you run some scenarios there. Now, what have we got here? That's radiant heat, right? That's the fire coming.
Yeah, so this is the actual fire front at some stage as it moves through the forest.
Okay.
We've got the structure. This is, in fact, the structure we were out surveying in the segment.
Yep, okay.
And this is the radiant heat analysis, which looks at how much each object can see of each object. So as they burn, they give different exposures.
Let's move on to the embers. This will show you how embers attack.
With various degrees of intensity as you move away from the source.
Yep. Okay, and now we have our results. Now, that'll show you run 100 scenarios, and in this one, for example, you find that 2/3 of them, the house has caught fire.
Sure.
And then to find out the weak point, you go here, window 1, window 2, and you see your weak point 90% of the time is window 1. So it tells you what?
That's a key weakness that you're going to have to address before you then try and consider issues of less importance.
So you fix window 1, then you run it again and find out where your next weak point here. And these lines here are various, it's information about where the house is vulnerable to embers.
Sure.
And you can use that to...
and you'll need to work through those as well to address the risk and bring it down to a level of risk that you can be comfortable with.
Lovely. Come across to the